Hello, Legacy students. Marsh here. So today we're going to talk about the rational zeros theorem, day 2. You want to have your notes out, and then today is a very important day to have a graphing calculator. So you're either going to want to find one in your bag or borrow one. Our essential question today: how can I complete the rational zero theorem faster? Because, last time we had to create the possible rational zero list, right? And then we were like, all right, well, the answer has to be somewhere. And then we started dividing a whole bunch of times until we got something that gave us a remainder of 0. Well, that was all fine and dandy, but let's see how we can do it faster. So, steps to finding all of our zeros that we're going to need. First, we're going to get a hint to get started. And that is the main focus of today, is how does one get, quote unquote, the hint? Okay, so that's main focus that we're focusing on today, is how does one get that hint? We set up division, we find the quotient, we factor the quotient if possible, and then we list all of our solutions that we've gotten. Same rules as last time. However, we're going to talk about how to get that hint. Now, something that's very, very, very important is the fundamental theorem of algebra. The fundamental theorem of algebra states that the number of solutions a polynomial has is equal to its degree. Now, these solutions can be integers, fractions, square roots, double counted solutions, which means you get the same answer twice, and then even an imaginary solution. Today, though, we're not going to be focusing on problems that give you imaginaries. We'll just have integers and fractions. However, we will look at a problem that has a double counted solution. So just keep that in mind. Ultimately, what we're going to be doing is we're going to be using the calculator. And we're ultimately looking for zeros, which is the same as solutions, which is the same as our x-intercepts. So ultimately, what we're going to do is we're going to use the calculator to give us a possible x-intercept that we can use to find the value on the outside. Here are our steps. We're going to push the y equals button. And in there, we're going to type in our function using that little X button. It says link above it. Go ahead and take it. It's the button below mode. We're going to tap graph. We're going to fix our zoom window. And then we're going to choose an obvious 0 to test the division. I'll be dragging in my calculator so you guys can walk with me on the calculator part. So, our first problem. Just like last time, let's generate our possible rational zero list, our P over our Q. So I'm going to figure out, I got to grab my pen here. There we go. I'm going to do P over Q. So that is my constant over my leading coefficient, so 3. Numbers that can make a 2 would be a 1 and a 2. Numbers that can make a 3, 1 and a 3. So my possible list of rational zeros is plus or minus 1, 2, 1/3, and 2/3 for my list. Now, last time we picked one of those numbers and we just went with it, right? But now, let's use the calculator. So first thing I'm going to do, I need to get this function typed in. I'm going to push y equals, which is right beside window. It's above second. And then it's going to take you into this y, and a whole bunch of y's. You're probably not going to have the color like I do, but that's okay. And then you're going to type in this. So I'm going to type a 3. And I need an x cubed. Whenever you want to type an x, you're going to push the button that's below mode to the right of alpha. It says xt theta n. I'm going to push that. Should bring an x up. Then I need to push cube. So I'm going to push the little caret key. It's the button below clear to the right of tan. Push 3. And then I'm currently in exponent land, so I do have to kind of arrow myself out of there. Now I'm just going to keep typing. Every time you want a minus, though, you do have to use the subtract button. If it's a negative number, so like let's say that would have been a -3 when I started, I would push the negative button. But anytime you want to subtract, you have to use the subtract button. So 2x squared minus 7x minus 2. There we go. Now, once I'm done typing, I'm going to push the graph button. It's right beside trace. And then your picture should pop up. Now, your zoom window could be off. And if that is the case, and what I mean by off, I mean by like a 10 by 10 grid. So I normally like to have my graph to be a 10 by 10 grid. To make that happen, you can push zoom, which is between window and trace. And then 6, Z standard. Z standard gets you a 10 by 10 grid. That's why we're using that one. And then it'll redraw it just in case your window was a little off. Now, what I'm looking for is a x-intercept. So I'm looking for one of these. These ones kind of look a little off. I like 2. 2 looks pretty x-intercepty. Okay, looks pretty close. So I'm going to drag my thing over here, and I think, if I remember right, there, I got my picture. So notice over here, sorry guys, my window is, I'm crossing the x-axis at 2. So we're going to set up our synthetic division, and 2 is also one of our possible zeros. So I have an x cubed column, an x squared column, an x column, and a no x column. I'm going to put a 2 on the outside, and then 3's with the x cubed, -2, -7, and -2. And then we're just going to complete our synthetic. So I'm going to drop the 3, multiply 6, I'm going to add, I'm going to get a 4, 8, 1, 2, and looky there. We got ourselves a 0. Now let's retranslate back to what we had. We now have 3x squared plus 4x plus 1. Let's factor. So 3x, x, a 1 and a 1, both positive. So my answers, I get -1/3. That's from that one when I would set that equal to 0. X equals -1 from that. And then don't forget the guy that started it all, Mr. 2. Now, if I look down at my graph here, notice -1 is probably and -1/3 is probably as well. And they were in our possible rational zero list. Now, you're probably thinking, well, Marsh, if we can just use the calculator, why do I have to do all this whole synthetic division factoring stuff? Well, I don't know if that fraction right there, I didn't know if it was -1/3. I didn't know if it was maybe -2/3. I wasn't really sure. So that's why we have to use it. The only reason we're using the calculator is to make it so that we don't have to guess and check all of these numbers. We get to just pick a 2 right off the bat. We don't have to think about it too hard. Let's try it again. Again, I'm going to set up my P over my Q just so that we have that possible rational zero list. So my P is 1. My Q is 4. Numbers that make 1, just a 1. And then numbers that make 4, a 1, a 2, and a 4. So my possible rational zero list is going to be, 1. That's not very helpful. 1/2 and 1/4. Okay. So again, I'm going to use my calculator. I'm going to drag in my calculator here. And I'm going to type this guy into my calculator. So I'm going to click the Y equals button. Again, that's right beside window. I'm going to push clear to get rid of the one we just did. And I'm going to type in my problem. Remembering, push this X button, the button below mode, if you want to get an X. So I'm going to type 4x cubed. I get out of the exponent land, plus 4x squared, get out of there, minus x minus 1. And then press enter. Now I'm going to push graph, which is right beside trace. And just in case maybe you messed up your thing, don't forget you do have that zoom Z standard. That will help you get that. It looks like I'm crossing through -1. And I think over here, I do have a better picture. It does look like we're going through -1. So let's try -1 on the outside. And I start with my x cubed column because that's my highest power. Notice the highest exponent is a 3, so that means we should get 3 answers out of this thing. A 4, a 4, a -1, and a -1. So I'm going to drop the 4. -4, 0, 0, -1, 1. It's almost like the calculator was not lying. I get a really awesome answer there of 0 for a remainder. So let's translate back. We now have, we started with an x cubed. We dropped an exponent, right? So we dropped an x. So this is technically going to be a 4x squared now. So I'll get 4x squared minus 1 that I got to set equal to 0. So now that is a difference of perfect squares. So 2x plus 1, 2x minus 1. So my two answers from those are x equals -1/2, x equals +1/2, and then don't forget the guy that started it all, -1. If you look at this problem, yeah, it's probably right? Look at your picture of your graph. Our last problem here, 2x cubed plus 13x squared plus 24x plus 9. Again, let's generate our P over Q. Now, I understand you're like, well, why? Well, the reason is because in case you wouldn't have ever a graphing calculator, you still need that possible rational 0 to start it all. So we generate that list because that's technically what we would be doing if we didn't have the graphing calculator to help us cheat. Kind of like loaded dice, stacking the cards. So P over Q, 9 over 2. So I'm going to get a 1, a 3, and a 9, and a 1 and a 2. So my possible rational 0 list is 1, 3, 9, and then 1/2, 3 halves, and 9 halves. Okay, drag in my calculator here. I'm going to push y equals, push clear. Now I'm going to type my stuff in. 2x cubed plus 13x. And then there is a squared button. I kind of always forget that it exists. It's below the inverse button, above the log button, plus 24x plus 9. Now I'm going to click graph. Okay. This one's kind of a weird looking graph. I'll bring it up so you guys can see it a lot nice and big over here on the thing over here. Notice what's happening. I'm bouncing right here. That is still an x-intercept, but when you see an x-intercept that bounces or a ricochet, that means you have a double counted root right there. That means we're probably going to get that answer, which is -3, twice. So keep that in mind. That is the only x-intercept that technically works here. So we're going to actually use -3 for our guy on the outside. And it looks like we started with an x cubed column, x squared, an x, and a no x. I'm going to drop the cube. Oh, whoops. Got to put my numbers. Silly Marsh. There we go. Drop the 2. Multiply 7, -21, 3. Oh, look at that. It's a -9. Okay. Translate back to math. 2x squared plus 7x plus 3. And we got to factor that. So 2x and an x, a 3 and a 1. 6x, there we go. So just like we said, we're going to get one answer of -1/2, which, yeah, it's pretty good with the picture. And then a -3, and don't forget, we actually technically have another -3. So what you could do is beside the -3, you could say it's a double root. That would probably be your best way to note that you have 2 -3s for your final answer. Something to note. If you start with an x to the 4th, so let's say your highest power was a 4, you can technically synthetically divide not once, but actually twice. So let's say you would get something right here that is not factorable. What you could do is you could pick another x-intercept from your picture, from your graph, and then you could just set up synthetic division with the 2, the 7, and the 3. That would be an option if you would need that. It doesn't happen all the time, but sometimes it happens, especially when you go above a cube for your highest exponent. That is the end of this video. I hope you enjoyed working with your graphing calculator, and I'll see you later, Sabers.